Hello to everyone, my name is Roman, and our work is a simulation of corrosion fracture of nanoconcrete at the interface with reinforcement, taking into account temperature change. And I would like to start with some introduction. Reinforcements for concrete constructions of the sewage network are made of steel. The efficiency of the system of transformation, cleaning, and disposal of dirty sewage depends on the thermal regimes of sewer pipes, which creates condition of potential environmental risks and emergency danger for the local population. Um, Corrosion processes take place on the interface between reinforcement and concrete in underground sewer pipes, which are facilitated by soil moisture. The result of condition is the formulation of micro cracks and uh, some cracks. Our outline contains six topics. The first one is purpose and task. After that, it's mathematical model for analyzing the influence of seasonal temperature changes on corrosion process and condition of concrete destruction. The next one is example of influence reinforcement concrete after corrosion in the metal surface in sewage network. And after that will be topic changes in indicator of anode current density according to the average temperature in Ukraine every month, and some difference between this value for the first and third year. And the last one topic is conclusion, the purpose and tasks. So the purpose of this study is to model some like anodic current in a track-like defect um, on the interface surface on the reinforcement, and to study its influence on corrosion destruction of nanoconcrete, taking into account temperature changes, the influence of mechanical loads, humidity, and diffusing oxygen. So to achieve this goal, there are several tasks. So that's prepare information for corrosion current, for thermal regime in surface defects and the interface with reinforcement, and to form criterion relations on a new mathematical model for analyzing the influence of temperature changes on corrosion process and condition of concrete destruction, and to form the criteria relations and optimization procedure of a new mathematical model for analyzing the influence of mechanical loads and thermal condition on corrosion process and the condition of destruction of nanoconcrete in the nanoconcrete rubber system. So, in general, the new mathematical model for analyzing the influence of temperature change on corrosion processes, which lead to the formation of corrosion pores at the interface between concrete and enforcement is formulated here, and in particular the basis of the new model is the Cauchy type ratio, uh, type ratio for the anodic current density, and a new comprehensive straight criteria for concrete, as well as an optimization approach for calculation interconnected parameters using neural network and a quality criterion, and taking into account the inverse relationship between the material parameters and corresponding initial values. So we are taking into account Cauchy type criteria of Griffith, Irwin, or Orowan, and criterion of straight here, as you can see, and some restriction, trouble-free operation, and multi-applicative, qualitative, quality criteria, and some criteria, quality criteria that is mentioned in the 7 formula, and some optimization of compressive straight, so as it's mentioned in the 9 formula. Okay, and an example of modeling the anodic current in defects on the metal surface in civil sewage network is considered. Constant humidity and temperature changes lead to the occurrence of corrosion processes, which cause the destruction of the structure over time. So the number of size of and number of the defects may increase under the influence of these external factors. Particular attention should be paid to places near stations or pipelines that are in a hot place. So since Ukraine is in temperature climate, there is an average temperature change of 279 Kelvin in the winter period and 294 Kelvin in the summer period. This temperature change causes the effects to increase due to the change of state. So as you can see here, we have the difference value, like and depends on the month, can be changed, like for each month. It's related to the average temperature. So, and here you can see some difference between these values, and the biggest difference, like in the values of the corrosion current, is in the summer months, and the smallest in the winter months. So here you can see some estimations of change. These indicators of like anode current density every 2 years based on the fixed calculated steps. So these values will increase every 2 years. And some conclusions here, that the first one is we have some changes in the like anodic current density in the corrosion pore or at the interface between nano-concrete and reinforcement takes a value of approximately 3% percentage, but it's enough to transform the pore into corrosion crack, and some mathematical model for analyzing the influence of temperature changes on the corrosion process is formulated here. So thank you for your attention.